Okay, good morning or afternoon, whenever you're watching this. So we are in week 3 of statistics, and we are going to study histograms and box plots. Okay, so I have some vocabulary as usual. Histograms is just a bar graph that is used to display the frequency of data divided into equal intervals. The bars must be of equal length. This means that the intervals that I'm referring to are just groups. You'll see right now that they're just the bars in the bar graph. However, histograms are not bar graphs, right? I know you know what bar graphs are, but in bar graphs are typically used to describe categories of things and comparing categories. Histograms is used primarily to display information that is continuous, that leads one to another, right? Okay, so there's that. There's box plots. Box plots display 5 number summary of set of data, and the 5 number summary is the minimum, the first quartile, the median, the third quartile, and the maximum. Okay, to give you an idea of what these things look like, I'm just going to give you a rough sketch of what they are, right? So if you notice, a histogram, right, looks a little bit like this. If you notice, it's continuous, meaning there's no space in between the bar graphs. All the bar graphs are tightly packed together. This is usually used to describe things like time or things like intervals that cannot be separated. So, for example, intervals that are in numerical order, for example. So, order is going to be really important for histograms. However, a box plot looks a little more like this. A box plot still represents, okay, so a box plot still represents data that's being displayed in a certain way. But the difference between a box plot and a histogram is the box plot kind of focuses on 5 key pieces of information, right? Known as the minimum, the maximum, your Q1, your Q2, and your Q3. And the Qs in this case do mean quartiles. So remember, I'm tying this in from the last lesson. So I hope you remember last week, right? And we're going to get into what this looks like with actual numbers. This is just what, so you have an idea of what things should look like and what these definitions are referring to. Okay, so how do we make a histogram? So I have 3 steps on the very top. Make sure you write these steps down before you go into them. Step 1 says arrange your data set from least to greatest. Okay, you're going to see that this is a pattern among a lot of things. Most data sets are going to be given to you in a random order. Why? Because when you take a data set, what you're doing is you're essentially taking down information from whatever source you're getting it from. And a lot of the times, like let's say you're asking people a question, your answers are not going to be in order, like ever, right? Which means that you are going to have to arrange your data set in order, right? Step 2, make an X and Y chart to organize your data set. Step 3, graph your intervals and data set on the X and Y graph. Okay, seems simple enough, right? But the truth is, making a histogram can take quite a bit of time, especially if the bigger the data set, the longer it'll take to make one of these. But the actual steps are not that bad. So let's take a look at the first step right here. I'm right here, right? Listed below are the scores from a golf tournament. Like I said, these are just scores. They're coming in. They're not arranged in order. We have the data set of 68, 78, 76, and it keeps going, right? Your first step, step 1, is to arrange your data set from least to greatest. So I've done that for you here. But when you're doing the problems for this week, you're going to have to do that first, which means you're going to have to look through the data set, whatever data set's given to you, and arrange them from the smallest number to the largest number. In this case, I have 68, 69, 70, 71, 71, 72, 73, 74, 74, 74. 75, 76, 76, 76, 177, and 178. This data set, again, is the exact same data set from before. I just arranged them in order. That's it. Okay, the next step is, remember, this was step 1. Step 2 is down here, and we're making an X and Y chart. You might be thinking, what is that? Well, an X and Y chart, I hope this looks familiar. It should have been from algebra. I am calling it an X and Y chart because maybe that's a little bit more familiar. But really what's going on is I have my data set, which is organized in something called an interval. Now, you've seen this word before. What does that mean? I said that interval earlier is referring to groups, right? And these groups have to be the same size. So what am I going to do in order to get that, right? Well, I have to take my data set and I have to find my range. I'm going to use my range to figure this out because I need to figure out how many intervals I need to make. You can have any number of intervals as long as the intervals within each group are basically the same. So what I mean by that is, let's find my range. My range here is my largest number, which is 78, minus my smallest number, which is 68. And that gives me a range of 10. Okay, so what do I do with this number? I have 10. Right? I really don't like that circle. Sorry. Okay. It was bugging me. Okay, so I know my range, right? It's 10. What do I do with 10? Well, if you notice here on my chart, I have a couple of different groups. I need to rearrange this range of 10 into sections, right? I know that I have 10 numbers in between my smallest number and my largest number, right? Now, some of those numbers are repeated, sure, and that's what the frequency is for, but I need to know how many groups. Think of the X and Y as kind of like a drawer, right? The score interval is a drawer, and if you have drawers in your house, you know that the actual cubbies are the same size. Each size of the drawer is the same, right? However, the amount of things you put in each drawer is different. That's what the frequency is, right? Your data set is just things you own, right? And they go into different drawers, right? That's one way of thinking about it. So how do I know how many numbers belong in each group? Well, since there's 10, right? I can probably make them in groups of 2. And that's exactly what I did. When you have larger numbers, you should use them in groups of 3, 4, 5. It doesn't matter. As long as each section has the same is the same size. So if you notice, each and every one of these, 68 through 70, 68 through 70, there's about 2, right? There's 68, 69, 70. Well, I guess there's 3, right? Then we move on to the next section, 71 through 73. It's the same amount, 71, 72, 73. So if you notice, there's like 3 in there, right? If we count the original one. Then the next section, it's 74 through 76. So 74, 75, 76. And the last one, 77 through 79. 77, 78, 79. If you notice, I'm counting like 3 in each one, right? Again, the range was kind of just there to help guide me, right? I know my range was 10, so I was like, maybe I should do groups of 2 or maybe 3, it just depends, right? And I started with the smallest number, right? If you notice here, 68 is the smallest number in my data set. And 79, it ended with essentially the largest number, but I don't have 79, I have 78. Well, remember when I said the sections had to be equal, right? Well, we have to make sure they're equal. So instead of ending it at 78, I ended it at 79 so that our intervals are the same size. Each interval is about the size of 3, actually. Because remember, 68, 69, 70, right? And then we move on to the frequency, right? So in this drawer, in this interval, any number that's 68, 69, or 70, I'm going to count how many numbers there are in my data set that belong in this group. So if we look at this 68, 69, 70, I have 1, 2, 3. That's how I got 3. Frequency is the number of items in that interval. In this case, items is just numbers. It's just data points. So there's 3 frequency. The frequency of data points in score interval 68 through 70 is 3. There's 3 numbers that fit into the 68 through 70 category. What about 71 through 73? Okay, so 71, 71, 72, 73. Okay, there's a little different. 1, 2, 3, 4. Looks like there's 4 numbers in there. Okay, that's different. What about 74 to 76? Well, 74 all the way to 76. Remember when I said numbers can repeat and this is going to make a difference? Well, this makes a huge difference because this one we have 1, 2, 3, 4, 5, 6, 7. We have 7 numbers, so I put 7 under the frequency. The last segment, the last numbers are 78, 77 and 78, which means there's only 2 numbers, and now I have my X and Y chart complete. Okay. Now, once my X and Y chart is complete, I'm going to graph this. Now, if you notice, if you look to right here, we're in step 3 now, and step 3 is this graph. Now, my score interval, right? My scores are my X value, which is left and right. If you notice the X and Y, this is the X, and this is the Y. So that's how I know where to put what, right? So I'm going to have different sections. If you notice, 68 through 70 is my first section, 71 to 73, 74 to 76, 77 to 79. Okay, now my frequency is my Y value or my up and down, right? The highest frequency I have is 7. You always want to go at least one higher than your highest frequency just because it then makes sure that your graph fits if you ever have to close it off. But for now, I went from 1 to 8 and I have little lines representing them. All right, so let's graph them. The first one, the score interval of 68 through 70, there's a frequency of 3. So I'm going to start in this line here, and I'm going to go up to 3. I want to connect it. Okay, no, that wasn't bad at all. What about 71 through 73? Well, I have 4, so I'm going to start this next line. Okay, this one's 3, and this one's 4. Okay, not bad so far. What about 74 and 76? That's 7, so that's going to go higher. There you go, 7. Okay, and the last one is 2, so that one's going to be pretty small. 2. Now, if you notice, unlike regular bar graphs, this is just by itself, right? It's by itself and they're connected. There's no space in between them. Why? Because the numbers don't leave any space. Remember, these aren't categories. These are intervals. These are groups that go one right after the other. So there really isn't any space in between them. That's what makes a histogram a histogram. With that said, we have just done the histogram for the data set for the scores from a golf tournament. Okay. All right, we're going to shift gears a little bit. And we're going to talk about estimating the mean of a histogram. You're going to get problems in this week. Well, not just about building a histogram, but what if we give you a histogram already built? Like if you notice this whole thing right here, what if I give you a histogram that's already completely built? All the numbers are there. It's all graphed for me. And they want me to do something called estimating the mean, right? So in other words, how can I find the mean without the data set? Remember, if I had the data set in front of me, all I had to do was just add them all up and divide it by the number of numbers. Easy, right? You guys did this like 2 weeks ago. However, that's not what we're doing here. What we're doing here is we're given the final product and we need to go backwards to figure out what the mean is. So if you notice the directions to doing this is right up here. To estimate the mean, find the midpoint of each interval and multiply it by its frequency. You might be thinking, what are you talking about? Midpoint? I don't get it. Well, I want you to look at this right here. If you notice here what I did, you're basically just taking the average. And this is your frequency. Don't get caught up with the word midpoint. That's just a textbook definition of it. But really what it's trying to say is the mean of the interval, okay? So, right, why don't we look at where it says first interval, right? The first interval, it says it's 20 plus 29 divided by 2. That looks kind of familiar, right? That's because what we're doing is we're taking this down here, 20 through 29. We're looking at the first group and the ages in that group. The ages between 20 and 29 make up the first interval. So I'm going to take the mean of that. I'm going to take the average of that. That's why I have 20 plus 29 divided by 2. And then I'm going to multiply whatever that is by my frequency. The frequency I'm referring to is of that particular interval is 20. That's where I'm getting it from. How high did that bar graph go, right? So what I ended up with is 20 plus 29, right? Should have been 49. 49 divided by 2 is this right here. 24.5 times 20. Remember, I didn't do anything till 20 yet. I put those in the calculator and I get approximately 490. Okay, so is that my mean of the whole thing? No, that's just my mean of the first interval. I have 5 more intervals to go because I have 5 more bar graphs to do. So I'm going to do the same thing for all of them. Let's start with the next group, right? We have 30 to 39. Let's take the average of 30 to 39, right? So 30 plus 39 divided by 2. Multiply that by the frequency. Frequency happens to be 25. Man, that looks terrible. All right, 20 to 25. 30 plus 39 ends up being 69 divided by 2, which is 34.5, times 25, which ends up being 862.5. All right, the numbers are getting larger, right? And that corresponds. These numbers should be getting larger because the graph is slowly getting bigger. The third interval, right? It's in between 40 to 49. I'm going to take the mean of that. So 40 plus 49 divided by 2 is 89. Divided by 2 is 44.5. Multiply 44.5 times the frequency, which happens to be 30. And I end up with 1,335, which is my biggest number so far, and it's my largest bar graph so far. Okay, fourth interval. It drops significantly. My bar graph in the fourth section should be smaller, so my numbers at the end should be smaller. We have 50 to 59. So we take the average of that once again. So 50 plus 59 should be 109 divided by 2 is 54.5. Then we multiply that by its frequency, which is 15. 54.5 times 15 gives me 817.5. Okay. Feel free to check these numbers, by the way. I mean, sometimes I make mistakes. So if I make mistakes, please call me out and leave me a private comment or something. Be like, yo, mister, you made a mistake here, you know? It happened the last time, so please double check my work, all right? That's how I know you're paying attention. So anyways, fifth interval, we get 60 to 69, right? We're gonna go ahead and take the mean of that. That's 60 plus 69, it should be 129 divided by 2 is 64.5. And then we're gonna multiply that by its frequency, right? That interval only went up to 10, so I'm only gonna multiply it by 10, which gives me 64.5 times 10, which gives me 645. All right, cool. So what am I gonna do with all those numbers? I have 5 numbers. Well, now that I've taken the mean of every single interval and multiplied it by its frequency, I'm gonna take all these numbers, all of these answers, right? And I'm gonna take the mean of those, right? Take the mean of all your answers. Okay, that means I'm gonna have to add up all my answers, and I'm gonna have to divide them by the number of numbers that I added up. So we're gonna have 490 plus 862.5 plus 1,335 plus 817.5 plus 645 divided by 5. Okay, so what do I get? I end up with something like 4,150 divided by 5. I know I don't have that there, but if you add up all those numbers, you should get 4,150. And we divide that by 5 because there's 5 numbers in my, in my problem. And that gives me 41.5. All right. Now, notice my last statement right here. I said a good estimate of this data set is 41.5. Why didn't I just say the mean of this data set is 41.5? That's what we were trying to find, right? Well, yes and no. The fact is, the only way to truly know what the mean is to know what the data set is. But if I don't have the data and all I have is this graph, this is the best way I can estimate the mean. Meaning that the actual mean could be like 41, or it could be 42, or it could be a little bit higher than that, or it could be a little lower than that. I have no way of knowing unless I have the actual data set. But in these kind of problems, like in the real world, sometimes you're missing information. And if you're missing information and you still need to know something, you need to find a way to work backwards from what you do know. And that's the whole point of this problem, right? If you are given a graph like this in the real world, right, and you're trying to figure out if it's actually valid, one way would be to find the actual mean and see if that seems reasonable for you. Don't have the data set? Well, you can always estimate it using this method. And if the actual mean of it, depending on the context, it could be, good, or it could be, no, that makes no sense. Again, we're going to go into those kind of things into later weeks, but bear with me, we're almost done. We just have to construct box plots now. Yes, I misspelled constructing. I forgot an S somewhere. Anyways, so we're going to switch gears, right? Now we're going to construct box plots. Again, 3 steps to this. This should not be that hard, okay? So we're just going to tack this on to the end of this lesson. What is a box plot? A box plot is another way of displaying information, specifically focusing on just 5 key pieces of information about a data set. The minimum, the maximum, quartile 1, quartile 2, and quartile 3, okay? All right, so if you notice right here, the problem, it says, use the data set to make a box plot. This is my data set, 3, 4, 8, and it goes on. The first step in order to make a construct box plot is order the data from least to greatest, right? Ordering my data from least to greatest, I did it for you. Right? We have 2, 3, 3, 4, 4, 4, 5, 7, 7, 8, 8, 9, 9, 10, 10, 11, 12, 12, 14. All right, they're in order. Let's move on to step 2. Step 2, identify 5 values that you need: your minimum, your maximum, your quartile 1, quartile 2, and quartile 3. Right here, I have the definition for what all of them are. So my minimum, it's just that. It's the smallest number in my data set, which should be if I arrange them in order, this is my minimum. Right? It's just 2. The maximum is the largest number in the data set, so that should be 14, right? Okay, now we get to the harder ones, the trickier ones: quartile 1, quartile 2, and quartile 3. Hey, this looks kind of familiar, right? Quartiles are something we've been working on, so this should be easy. Okay, so one problem, right? Very minor problem, but still a problem. We always want to start with quartile 2. Why? Because quartile 2 is a median, if you remember from last week. In order to find quartile 1 and 3, we kind of need to find quartile 2 first, because we need to orient ourselves where the middle is. Problem. There's an even number of numbers in this data set. There's approximately 20 numbers in this data set. That's an even number, which means there isn't going to be one single number in the center. The center of this data set is between 7 and 8. It's between these. So if it's in between 7 and 8, what do we have to do? According to last week, we have to take the average, right? It's somewhere right here. Now, if you notice here, I have the average is, you add both numbers, right? 7 plus 8. And then you're going to divide it by 2 because you're adding two numbers. You end up with 15 divided by 2, and then 7.5. 7.5 is my quartile 2. Okay. Okay, so I know what my quartile 2 is. So what? I still need to figure out what quartile 1 and quartile 3 is. I'm not done. All right, so why don't we start with quartile 1? That's everything to the left of that line that I drew belongs to quartile 1. So I need to find the numbers in the middle. Again, that means that there's 10 numbers to the left of quartile 2, right? Because that 7 technically isn't the median. That 7 that we see there belongs to quartile 1, which means that there's two numbers fighting for the middle, 4 and 4. Again, right? So again, 4 plus 4 divided by 2. Just so you guys know, if you ever are trying to take the average between two numbers that are identical, it's always going to end up being that number again anyways. Because look, 4 plus 4 is 8 divided by 2. Hey, look, 8 divided by 2 is 4. 4 is going to be my quartile 1, right? Okay, so my quartile 1 is going to be in there. That's going to be there. Same thing. I'm going to do the same thing for quartile 3. That 8 that you see to the right of the quartile 2, that belongs to quartile 3. So I need to find the numbers in between. And the numbers in between happen to be 10 and 10. Oh, that was lucky. Why is that lucky? Because I just told you there was a trick, right? If there's two numbers that are the exact same thing, and you're trying to find the average between them, it's going to end up being that number again. Okay, good. So I have all my numbers. So what? What do I do now? Well, now you just have to actually draw or graph your box plot. And what do I do? Well, first I'm going to start with the line, and then I'm going to label them. Right? I need to make sure all my data set numbers can fit on this line. So I started from 0 to 16 because I wanted it to fit and I didn't want it to be at the end. Then I'm going to graph all 5 points first. Right? So I need to graph my minimum 2. So I'm just going to put a dot right above 2. I need to graph my quartile 1, which is 4. So I'm going to put a dot right above 4. I need to graph 7.5, which is my quartile 2. That's in between 6 and 8, but a little bit closer to 8 because, again, it's 7.5. I'm just going to approximate it. It doesn't have to be perfect. You just have to show me that you kind of know where everything is. Okay. So then we have our quartile 3, which is 10. So I'm going to put that right above 10. And then we have our maximum, which is there. So if you notice, I should have 5 dots right above their corresponding numbers on each line. Okay, so what do I do now? Well, another name for a box plot is a box and whisker plot. You might see a term like that on the internet, or if you're like trying to look up some more help on this or other videos, you can look up the term box and whisker plot. The reason why is quartile 1, 2, and 3, they need to be inside the box. So we're going to draw a box, and it's going to go through these points. I guess this one should be like that, right? Let's sorry, let's redo that. That was really bothering me. Now, you know what? That's good enough. Okay, so there's the box, right? The box goes through quartile 1, quartile 2, and quartile 3. I got to make sure to put a line through there. And you should know these forwards and backwards. If I give you a completed box plot, you should be able to tell me where everything is. And depending on which dot is where, you should immediately be able to tell me where everything is by just looking at it. You should also be able to plot points if I give you minimum, maximum, quartile 1 and quartile 2, quartile 3, and tell you, hey, can you graph these? You should be able to draw a box like this plot them wherever they need to be. Okay, what about minimum maximum? We're just gonna connect them with a line, right? They're not inside the box, but they're definitely connected to it. They're definitely related. They definitely have something to do with each other. That's my minimum, and that's my maximum. All right, good. Looks like I'm done with that. That is my box plot. And this box plot displays important information about the data set, right? Instead of having to look at the data set and be like, okay, which one's my smallest, which is my large, it shows me visually what that is. So if I have a data set and I have a box plot about that information, it already tells me valuable information, right? Believe it or not, most of the information is inside that box, quartile 1, quartile 2, and quartile 3. The minimum and maximum, I guess you could consider them outliers. We'll talk more about outliers later, but for now, just know that this is what I expect. You should be able to graph one of these if I give you all 5 of these, right? If I give you a data set, you should be able to go through all these steps and graph one of these. And if I give you one of these completed, you should be able to go backwards, look at the graph, read the graph, and tell me what's the minimum, quartile 1, 2, and 3, and what's the maximum without doing any math, okay? So that's all for today. Go make sure you have all this written down, and good luck.